Here we're starting week 17. One thing that's nice, it's a lot of review. Factoring is a huge concept in math, so we're going to keep practicing it. Complete the diamond problems and factor the following area model. So in this problem, we want to figure out what numbers multiply to 12 and add to 7. I usually joke around like ask your ma for help, multiply, add. So let's see, the numbers I can think of that multiply to 12, so I have to think 1 times 12, 2 times 6, 3 times 4. I'm going to go through the list, and this is kind of a methodical way if you don't see the numbers right away, is just to list 1, 2, 3, and then the next number is 4. But see how I've already used 4 up here? So that means I can stop. I don't have to go because it's just going to be 4 times 3, 6 times 2, 12 times 1. But out of this set of numbers, which ones can I get a 7 out of? It's the 3 and the 4. And if I say negative 3 and negative 4, a negative 3 times a negative 4 makes a positive 12. When I add two negatives together, I continue to get a negative. So that's how you do the diamond problem. In this problem here, it's what number we want to, figure this out. This is usually upside down. I usually put the x squared here. But I know I'm going to have an x here and an x here, right? X times x makes x squared. This is not just an x squared, it's a sixth. But I can see here that if I put a 2 here, 2x times 3x will give me 6x squared. Then 2x times 1, and then 1 times 5, and then let's double check 5 and 3. 5 times 3x makes 15x. Everything lines up. It's columns and rows. So these are our factored form. 2x plus 5, and then I'm going to write the x first. 3x plus 1. That's our factored form. Okay. So we're going to do the diamond problem to factor the following equations. That was just practice. Here we go on our first problem. We're going to set this up by drawing our box. The first x squared here, the last number here, you multiply those two, and you get 15x squared. And then this b on the bottom goes here. Now we're playing that game. What multiplies to make 15, sorry. What multiplies to make 15 and adds to make 8? So I can easily see, 3 and 5, and it's going to be negative 3x and negative 5x. So negative 3x, negative 5x, those numbers go in our box. And then we're going to see what multiplies together. It's nice when there's just an x squared because it's x and x. And then we can see this is negative 3. Negative 3 times x is negative x. And then negative 5 times x makes negative 5x. So these are my factored form right here. We have an x minus a 5, and did I double check? Negative 5 and negative 3 make a positive 15. Yes, x minus 5, x minus 3. Okay, that's my answer. Factored form. Here we go again. We're going to make our box. I'm learning to make my box a little bit bigger so I can fit everything in it. 2x squared, and that's a negative 20. And when I multiply those, I get negative 40x squared. And this bottom number, remember, or this middle number b for bottom. What multiplies to make 40 and adds to make 3? Nothing pops in my head right away, so I'm going to go 1 times 40, 2 times 20, 3, nope, 4 times 10. Nothing makes 3 yet. 5 times 8. Oh yeah, 5 and an 8. See how they're 3 apart? I can multiply them, 5x and 8x. I want a positive 3, so this number becomes negative. The bigger number stays with the positive. The bigger number always gets the sign of this bottom term right here. So we have negative 5x and 8x. Negative 8 times 5 makes 40. 8 minus 5 equals 3. So now that we have set up our box, we can start going, okay, this is going to be a 2x and an x, right? But look at 2 times something doesn't make 5. So let me switch the 2 and put it over here, because I can see 2x times 4 makes 8. And I can just put a negative 5 here, x times negative 5. And let's check. 4 and negative 5, that makes a 20. So here are our terms, our factors. So factored form, that becomes x plus 4 and 2x minus 5. X plus 4 and 2x minus 5. I'll make it a little bit neater right there. All right. So factoring. There are some cool things to look for. Here are some special cases. And special cases is the difference of perfect squares. So if you have like x squared, see how that's a perfect square, x times x, and you have a 4, that's a perfect square, 2 times 2. As long as there's a minus between them, then you can just write it as x plus 2, x minus 2. And let me just prove that to you. If I draw this in my little square, I'm going to get x squared and negative 4. Notice there's no middle term, so it's a 0x on the bottom. What multiplies to 4x that I can get a 0? A 2 and a negative 2. Negative 2x and 2. So that becomes x and x, negative 2 and 2. So see, x plus 2x minus 2. So I did all this work, but if I can notice right away that there are perfect squares, like this is 5x times 5x, and this is 1 times 1, if you can recognize that two things are perfect squares, you can just write it as the sum and difference of those two squares, and that's all you have to do. 5 times 5 makes 25, 1 times 1 makes 1. All right? And then this one's not quite as obvious, but if this is a perfect square, so you have 3x times 3x, and this is 2 times 2 makes 4, then you can write that as 3x minus, because there's a minus there, minus 2 quantity squared. But let me show you why that works. Let's go here to our little, I'm going to get 9x and I'm going to get 4. So when I do cross products, I'll do the cross products on this side. Get 36x squared, that middle number goes on the bottom. What can you think of that multiplies to 6, or 36, that I can get a 12 out of? How about 6 and 6? I need a negative 12, so they're both going to have to be negative. So negative 6x, negative 6x. Now when we go here, oops, I forgot to write the 9x squared. Let me write the 9x squared in my little box. I can see that this is supposed to be 3x and 3x. Now 3x times what makes 6? Negative 2. Oh, and it's 3x times what makes negative 6? And negative 2 times negative 2 is 4. So these are that's my factored form, 3x minus 2 times 3x minus 2 again, so I can just write it as squared. But again, if you can notice, see that this first term and this last term, if they're perfect squares, and then you're going to use the sign of the one in the middle. Well, now I just made it so you can't see what it is. I'll highlight it. And then you would just write that as 3x minus 2 squared. So things to look for to make your life a little bit easier if you have a difference of perfect squares or a perfect trinomial square. This concept, looking for the perfect trinomial square, we did not spend a lot of time on it in the past, just because learning to factor was hard enough. But now that you guys are more skilled at it, if you can look for that pattern, it will help you. You can always, every single problem, make the square. It's not a big deal. And then let's look at this page that you're going to do for homework, page 8. Okay? All it is 8 problems to factor. You're going to do the diamond problem on all of these and look for where there's perfect squares. So I'll give you a hint, like number C, number E, and that's all I see is those two, C and E. Those are the ones you can use a trick on. Everything else I think you have to work out the long way. It's not really that long. All right? Do page 8 for homework. Have a great day.